Alright, so I'm going to show you the lab 1 for ECED2200 part 1. So for the first part of the lab, we're going to use these binary explorer boards. So the first thing to do is plug it in, and it may or may not do some sort of counting sequence. As long as this power light's on, everything's working. So depending on the position of the switches, it might do other stuff. What we need to do first is erase everything that's in this, because this will interfere with what we need to do in part 1 of the lab. So I go to the newae.com/teaching, and I need to download the eraser program. There's a direct link in the procedure. So the procedure you can download from here. And here's the BORA eraser. So this is referenced in that PDF somewhere. But anyway, download that. So this will open a zip file. You just click on it. The first thing you need to do is copy it out. Do not try to run it from within this zip file. It won't work. So I'm just going to go ahead and copy this to the desktop. All right. Now what I'm going to do is open this and run erase.bat. So I'll double click on erase.bat, and it'll ask you about this, and just hit run. So a little thing will come up here and run some various crap. Takes a minute to go through. This assumes you already have drivers already set up for the binary explorer board. If you don't, you'll have to install them, which are linked from elsewhere. If you're in the lab computers, these will all be completely set up already. So loofah JTAG. Anyway, so this runs. It says scan device output which matches, and you hit enter. What you'll notice is that these LEDs are slightly on, so you can see it's not as bright as before. There's sort of a dim illumination. And this is what's known as the bus keepers on the output of the CPLD. So for example, you could just connect these LEDs straight to a switch, and you can see how the LEDs go either completely on or completely off. So when the output is 1, you notice that it's on completely. When the output is 0, it's off completely. If it's floating, it sort of does this half-assed on-off state that's not quite as bright. So in part 1, we're going to use some physical logic chips. So for example, I have here a 74, I don't know if you can quite read this, 7404 device. Let's see if it'll focus in. The camera may not focus this close. Anyway, so it's a 7404. So all we do is, which actually isn't one of the examples you'll be using, but the whole method is the same. You just need the pinout of it. So I could just search 74 pinout. And I learned that, okay, well, pin 14 is VCC. So again, remember that I need to use this notch. So at the top part here, there's a little notch indicating that the orientation of the chip. So this is pin 1 here. And this notch sort of corresponds with, in the pinout diagram, the notch you see there. So that notch means pin 1. So the first thing you have to do is connect up ground, which is pin 7. So I'll just run it to a ground here. And then this pin 14. So if you look on the physical device, pin 14 at the top, I need to connect to plus 5 volts. So that's this rail here, this plus 5 volt rail. Don't use the plus 3 volts or these devices won't work. All right. So what is this? So this chip is actually just an inverter. So there's just one input and one output. So 1A is an input. So I'll connect that to a switch. So now this switch will be the input and output, or the input, which is either 1 or 0. And then the output I'm going to connect to an LED. So now I can confirm the truth table works. So if I set this switch to the left, it's putting a 1 in, so the switch is all the way to the left. So it's in the 1 state. This means this wire here, the input wire, is 1. I look at what the output is, which I've connected here. So I've connected this output to this LED, and I can see the LED is off, so the output is 0. So I can make a truth table. I can say A, Y. So A is 1, Y is 0. And if I set A to 0, we can see the output becomes 1. So when A is 0, Y is 1. So this is the truth table for a NOT gate. So in the lab, you'll be verifying all of these truth tables work as expected. If you have 2 inputs, so for all your gates will actually have 2 inputs, the AND gate, etc. All you need to do is you'll connect 2 of the switches like that, so you'll plug that into a switch, and then you'll have a third wire here that'll be your output wire. So for example, if this is the output pin, and check the pin out because they do vary, you'd connect that there. So that's how you do part 1 of this lab.